Now we have come to a major topic: applications of Bernoulli's theorem. First one is lift force of an airplane. Lift force of an airplane. So when we if you look at essay questions from Bernoulli's effect, complete essay question can be given from these types of these applications. I mean, from this first application, the complete essay question is based on this application alone. If you take another application, the complete essay question is based on that application alone. So when you take the what the wing of the plane, if you look from let me draw an airplane. Okay, it is somewhat like this, right? There is this wing here, like this. Okay, right, this is the front. Okay, what I am discussing is about this shape. So I'll draw it again. That has a very distinct shape like this. Okay, the shape of the wing is like this. When looking from this angle, okay, when looking from this angle, this is not this section. Okay, this is this one enlarged is this one, right? Now the thing is, when this goes when the airplane goes, then when the wing goes, air particles move relative to the wing in this direction. This can go like this, and another air particle somewhere here can go like this, and this air particle, it can't go through the wing, so it will just go up like this and go like this. This air particle will also go like this, and this one, it will go like this. This is the flow of air particles relative to the wing. Now you can see that if you consider this as a flow of tube, the area at this position is high, and area somewhere here is small. So let's take two positions, this as x and this as y, this position as y. Let's write data relevant to this x position. Let's take pressure at this position as P1, and velocity as v, and pressure at this position as P2, velocity as u, This is P2, velocity is u. Okay, now I didn't put arrow here, but you have to know that now from these notations you can understand what this is, right? This is a pressure P1, velocity is v, this is P2, and velocity is u, right? If you consider the gap between these streamlines, these positions, all of these positions, velocity is same, right? It is unaffected. At this position, at below the wing also, at this position also, pressure and velocity are not affected, right? Velocity is same, pressure is also therefore same. Velocity is constant and pressure is also constant. I can write conditions at this place and conditions at this place are same, but this is different. Why? Streamlines they have come closer to each other. So when I apply Bernoulli's equation for these two places, when I apply Bernoulli's equation to these two places, the in the space given you have to write like this. So when you are applying Bernoulli's equation, you have to write considering x and y points along the streamline. Okay, why we have to write like this? Because Bernoulli, in the Bernoulli's equation, the equation says that sum of pressure plus kinetic energy per unit volume and potential energy per unit volume is constant at any place along the streamline. So we can apply the Bernoulli's equation only along one streamline. Okay, so x and y points, we can apply the Bernoulli's equation. Let's apply the Bernoulli's equation. So here pressure is P1 plus half rho is the density of air here, rho V squared plus rho G H term. When we consider these two places are relatively at the same level. So we don't consider a height difference at these two places. So we'll just consider this as horizontal case, the horizontal pipe case, right? So P1 plus half rho V squared equal pressure at this place is P2 and velocity is half rho U squared. So what is the higher velocity? U is the higher velocity. Let's take this term to this side and P to this side. So P1 minus P2 is equal to half rho U squared minus half rho V squared. This difference is a positive value. Why? Because that velocity is high. Area has become smaller, so therefore velocity should be high. Therefore pressure at this should be P2 should be small. Pressure at this P1 should be high. So P1 minus P2 is a positive value. These two, the subtraction these two terms are a positive value, positive answer. Here I can write P1 minus P2 equal, I can take rho over 2 out and write U squared minus V squared like this. Okay. So this is the pressure difference acting between these two places, but this place and this place are similar, right? So I can say there is a pressure difference acting between these two places also. The same pressure difference acts between these two places also. But the thing is, I can't apply Bernoulli's equation for this place and this place. I can't take this as x, this as y, this as y, this as x, and apply Bernoulli's equation to these two places. Why? In the Bernoulli's theorem, it says that it should be along one streamline, only one streamline. These are two separate streamlines, so I can't apply Bernoulli's to these two places. But I can apply, I can say that these conditions are same, so therefore this pressure difference acts between these two places also. From P1 to P2, from higher pressure to lower pressure, there is a force acting. So you have to draw this. There is a force acting now. From P1 to P2. This is what we called the lift force. This is the force that is causing for the train to lift up. How to take that force? Force equal pressure times area, right? Force equal pressure times area. Pressure is this one, this thing, rho over 2 U squared minus V squared, and you have to multiply it by area. Area is actually the area of this base section, area of the base, right? If we know the area, then we can take this product and find that magnitude of the force. Okay. So after that, the if we take there are two wings. Normally there are two wings, so there will be another force on the other wing also. If we take if we consider um, the sum of those both those forces as F. So if F is greater than mg, if F is greater than mg, that means if the resultant force due to both the wings is greater than mg mass weight of the plane, then the plane will lift up. Or if the force is less than mg, then the plane will descend, plane will come down. Or if f is equal to mg, then the plane will stay on the same horizontal level, it will go horizontally, right? You have to draw this diagram in the top space, and in the next space you have to write this part, and below the effective area line you have to write this part. The last thing you have to learn in this section is always this lift force is always perpendicular to the base of the wing. It is always perpendicular, it is like this. Okay, so if the wing has incline like this, incline to a theta angle, then this force is now inclined because it should act perpendicularly, so this inclination is also theta, this is also theta, this inclination. So if the wing has inclined theta like this, the force has inclined theta with the vertical direction. You can take this, right? This is theta, this is 90, this is theta, this is 90 minus theta, this is 90 minus theta, this is 90, so this should be theta as well. Okay, draw this below the last paragraph. The lift force is always perpendicular to its wings. Below that paragraph, draw these two diagrams.